Okay students, now we'll study about the shear force diagram and bending moment diagram for simply supported beams. You consider this simply supported beam AB subjected to a centrally concentrated load W. That means span AC is L by 2 and span BC is L by 2. First of all, in a simply supported beam, in order to draw the shear force diagram and bending moment diagram, what we have to do is we have to find out the support reactions. So in order to find out the support reactions, we must know what are the reactions acting at the support. Now this support A is a hinge support and support B is a roller support. We know that in a hinge support there are two unknowns, a vertical reaction and a horizontal reaction. But in this support A, there is only one unknown reaction, vertical reaction, since this beam is not subjected to any external horizontal loads or inclined loads. So support reaction at A is RA and support reaction at B is RB. First of all, let us take the equation of equilibrium sigma V equal to 0 in order to find out the unknowns. So when you take sigma V equal to 0, what are the vertical forces acting? Vertical forces are RA and RB acting upwards and W acting downwards. So let us write the equation as RA plus RB is equal to W. So let this be the first equation. Now let us take moment of all the forces about B and equate it to 0. Now what is the moment of this W about B? W is acting downwards and this is creating an anticlockwise moment about B. So what is the moment? Load into distance, W into L by 2. So let us write here W into L by 2. Now what is the moment of RA about B? RA is acting upwards. It is producing a clockwise moment about B. RA is trying to rotate this momentum AB in the clockwise direction about B. So we can write here this is equal to RA into L. Since RB is acting through the moment center, there is no moment of RB about B. Now from this equation you will get the reaction RA is equal to W by 2. Now when you substitute this in equation 1, you will get RB is equal to W minus W by 2, which is equal to W by 2. So now you know the reactions at A and B. RA is equal to W by 2 and RB also is equal to W by 2. So whenever you get a beam like this which is symmetric with respect to loading and geometry, we can write the support reaction as half of the total load acting on the beam. Now let us find out what is the shear force at different sections. For that you first of all consider a section line XX at a distance small x from the right support. Okay. So when you take moment of the forces, let us take shear force at XX is equal to this W by 2 is acting upwards. Now what is our sign concept? Our sign concept is right downwards is positive, but this is acting upwards, so it is negative minus W by 2. Shear force is the unbalanced vertical force to the right of the section, which is equal to W by 2. Now let us take find out what is the shear force at x equal to 0. At x equal to 0, shear force at B is equal to W by 2. Now we will find out what is the shear force at x equal to L by 2. At x equal to L by 2 means shear force at C, which is again equal to W by 2. But this is right upwards, so it is negative. So both these values are negative. Now let us consider another section line at a distance x from the left support. Let the section be x1, x1. So you consider a section line at a distance small x from the left support. So let us write the shear force at this section. Shear force at x1, x1 is equal to, again, what is the unbalanced force? It is the reaction W by 2. Now here our sign concept is left downwards is negative. So left upwards here, this RA is acting upwards, so it is positive plus W by 2. Now what is the shear force at x equal to 0? At x equal to 0 means shear force at A is equal to W by 2. Now we have to find out what is the shear force at x equal to L by 2. that is shear force at C, again equal to W by 2. Now let us draw the shear force diagram. For that, first we have to draw a baseline which represents the centroid or the center line passing through the beam. So first we'll draw the shear force at B. Shear force at B is minus W by 2. So we are drawing negative values below the baseline. So this is minus, this is W by 2. Now what is the shear force at B? Shear force at C, the center, it is again W by 2. So let us draw this point. This is again W by 2. Now we can join these 2 points. This is W by 2. Now what is the shear force at A? Shear force at A is plus W by 2. So let us draw it above the baseline. So this is W by 2. Now what is the shear force when you take the section from the left? It is at C, it is again plus W by 2. Now let us join these 2. So this is the shear force diagram. Above the line we have positive and below the baseline the shear force is negative. Now we can hatch this. And you have to write SFD under the figure. So what are the salient features we have marked? We have marked the shape, we have marked the maximum values, we have marked the sign, and below that you have to write SFD. So these are the things you have to draw while drawing the shear force diagram. Okay, now let us draw the bending moment diagram. Now what is bending moment? Bending moment is the unbalanced moment to the right or left of the section. So first let us see what is the bending moment at x1, x1. Bending moment at x1 is x1 equal to W by 2 into x. So what is our sign concept? Left clockwise is positive. So this reaction RA, when you take moment about the section x1, it is producing a clockwise moment. So it is plus W by 2 into x. Now at x equal to 0, that is, what is the bending moment at A? This is equal to 0. When you substitute in this equation x equal to 0. Now at x equal to L by 2, that is, what is the bending moment at C? W by 2 into L by 2, which is equal to WL by 4. Now what is the bending moment at section x, that is this green line? What is this bending moment? It is again W by 2 into x. Now our sign concept is, what is our sign concept? Our sign concept is left anti-clockwise is positive. So again here you can write bending moment at xx is equal to W by 2 into x, which is also positive. Now at x equal to 0, that is M at B, this is equal to 0. Now at x equal to L by 2, that is bending moment at C, this is equal to W by 2 into L by 2. So you will get the moment as WL by 4. Okay. So you have got bending moment at all the sections. Now we can draw the bending moment diagram. So in order to draw the bending moment diagram, let us take, first you have to project this line downwards. We have to project this line downwards in order to draw the bending moment. The end of the beam, the center of the beam has to be projected downwards. So what is the bending moment at this point? Bending moment at A is 0, bending moment at B is 0. Bending moment at C is WL by 4, maximum value. So the variation is linear, that is W by 2 into x. So this value, maximum value, is WL by 4. This is 0, this is 0, and this is a sagging moment, bending moment. So positive. Now you have to hatch this diagram and you have to write here bending moment diagram. Okay. Now let's see how to draw the shear force and bending moment diagram for a simply supported beam subjected to UDL. First step is we have to find out what are the support reactions. So in order to find out the support reactions, let us take the equation of equilibrium sigma V equal to 0. When we take sigma V equal to 0, you will get RA plus RB is equal to W is acting for L length. So W into L, where W is the load per unit length. Now let us take moment about B equal to 0 and equate it to 0. So what are the moments? So first of all, we have to assume what are the reactions. So what are the reactions? Since there is no inclined or horizontal load, reaction at A is RA and reaction at B is RB. So when you take moment about B, we can write RA into L is equal to W into L, and this will be acting at the center, and we can write into L by 2. That is distance from the center C to B is L by 2. Okay, this is L by 2. So moment of RA about B, moment of load acting at the center will be equal to W into L, and distance is into L by 2. So we can write RA is equal to WL by 2 and RB is equal to WL minus WL by 2, which is equal to WL into 1 minus 1 by 2, which is equal to WL by 2. So you have got the reactions. So RA is equal to WL by 2 and RB is equal to WL by 2. Okay. Now we can write the shear force. So for that, first of all, let us consider a section line XX at a distance small x from the right support. So this is XX at a distance small x from the right support. So we can write shear force at XX is equal to WL by 2. That is the shear force is the force due to this one, WL by 2. And what is our sign concept? Right downwards is positive. So this WL by 2 is this value, is this acting upwards. So minus WL by 2. Now what is the shear force due to this load? This here you have a W per meter, W for X distance. So total load is, this is acting downwards, right downwards is positive plus Wx. Okay. So we can find out what is shear force at X equal to 0. That is F at B. At X equal to 0, this becomes minus WL by 2. Okay. Now we can find out what is shear force at X equal to L by 2. That is shear force at C is equal to W minus WL by 2 plus W into L by 2. So shear force at C is equal to 0. Okay. Now we have to let us take another section line from the right support. You consider a section line x1 from the left support. A shear force at x1 is equal to WL by 2. That is left upwards is, our concept is right downwards is positive. So left upwards is positive plus W by 2. This shear force due to this load for X distance is left downwards is negative minus W into X. Now we can find out what is shear force at X equal to 0. That is shear force at A is equal to plus WL by 2. Shear force at X equal to L by 2. That is shear force at C is equal to WL by 2 minus W into L by 2, which is equal to 0. Okay, now we will draw the shear force diagram. Shear force at B is equal to minus WL by 2. So let us draw it below the baseline. So this is WL by 2. Shear force at C, you have got it as 0. So at center, this is equal to 0. So let us join these two lines. The variation is linear because shear force varies with X. Now you have got shear force at A is equal to plus WL by 2. So this is positive. Shear force at C equal to 0. We can join this. So this is SFD. Now we can hatch this. This is minus and this is plus. So this is how to draw the shear force diagram for simply supported